Hi, welcome back to another short C# video in which we will go through the creation of a simple dispatcher that can be used to send commands and queries, or instructions as I collectively call them. With just a few lines of code and leaning on your favourite IOC container, you can create the infrastructure to work with patterns that use command and queries such as CQS or CQRS. As a side note, I have found over my years spent as a developer that when you're stuck with a problem, quite often if you turn the problem upside down, you find a solution. About 10 or 15 years ago now, I used facades in my end-tier apps, such as a client facade that would have contained most of the methods for working with a client, and within each method there would typically be calls to repositories and services. The architecture was sound, but over time some of the classes did get large as more methods were added. After one large project, I read about commands and queries, and it just resonated with me. Instead of having classes with many methods, you could flip it on its head and have a handler class with a single method that would process the command or query, aka the method arguments. I think it was around 2016 when I created this dispatcher, and it hasn't changed since, as it still does exactly what I need it to do. Just send commands and queries, nothing more, nothing less. As I wanted to update the syntax to be in line with a couple of new C# features, I thought I'd revisit it and share it with you, hence this video. I should point out that during the making of this video, I decided to copy the code shown within this video and reorganize it into two projects so I could create a NuGet package and a demo project. So the link to the source code is for the reorganized project, but the code within it is exactly the same as this video. So, what are we looking at? A simple console application that uses a simple dispatching mechanism to send instructions to be processed by instruction handlers, hence the name, Instruction Dispatcher. Before we run the application, let's quickly run through the main method and what our expectations are. We expect that when we send an instruction, whether it be a command or query, that the dispatcher will somehow pass that instruction to a handler that knows how to process that specific instruction and then return some sort of result, or indicate that there is no result for a more pure type of command. The code. On line 21 we get an instruction dispatcher from an IOC container, currently autofac. In reality, this most likely would have been obtained via constructor injection, perhaps in a web API controller. We then mimic receiving some data object by creating some customer data class. On line 25 we create an add customer command, giving it the new customer data, and have the instruction dispatcher send it to be processed by a handler that knows how to process it. The return type for this is a task of none. The none type, more commonly known as a unit, indicates that there is no meaningful return value, so we just discard it. We then send another instruction, the get customer query, which returns a task of customer data which we have written to the console, and as the customer data type is a record, its toString method will output its property values. Let's run the application. Nothing too exciting, but as you can see there is some stuff written to the console that wasn't mentioned, so it looks like our instructions were processed by handlers, which is exactly what we wanted. Let's go through the code to see how it worked so you can build your own dispatcher. You can also use my source code as a starting point, or NuGet package if you don't want to roll your own. The link to the GitHub repository is in the video description below. The all simples type file just contains a couple of types used in the demo, a none type to signify no return value and a record class for customer data. For those not familiar with CQRS, commands shouldn't return data, that's the job of queries. However, I'm pragmatic, and if you need to say return an ID from a database via an issued command, I won't say anything. As we will see shortly, the instruction interface used by both commands and queries requires a type, which is the type that gets returned from handlers. For commands that don't return any real value, like our add customer command, you would use something like the non type, or what is usually termed unit, for the return type to satisfy the interface. As another side note, for many years I have also used what some call a return type that every method returns. The type I created for this style of programming is called flow, but that's another video for another day. Next, the add customer command handler file. I like to put both the command and handler in the same file so you can see everything, plus it halves the number of files, but you do not have to take this approach. In this file we have the add customer command class that implements the instruction of tValue interface, which is actually just a marker interface to constrain the type used in the handler, in this case the non type. The add customer command handler implements the iCommand handler interface that has two type params, an instruction closed by the add customer command type and a return type closed using the non type. The underlying interface only has a single method, handle, that returns a task with our return type, in this instance the non type. As the comments suggest, you would normally have objects injected into the handler, such as a repository or DB context, using your chosen IOC container. Next, the getCustomerQuery and getCustomerQueryHandler classes. Just like the addCustomer command, the getCustomerQuery implements the iInstruction interface, this time specifying the customer data type for its type param. The handler implements the iQueryHandler interface and its handle method. As we will see next, both the iCommand handler and iQueryHandler interfaces are themselves marker interfaces that implement an iInstruction handler interface, that is the expected type, by the dispatcher. The first interface in the interfaces file is the iInstruction interface that has a single generic type parameter, tValue. tValue is what we want as the return type for the instruction handlers. On line 7 we have the iInstruction handler interface that has two generic type parameters, an iInstruction and a tValue. We use a constraint to enforce the first type parameter to be that of an iInstruction interface of tValue, also specifying that tValue should not be null. The tValue is also constrained by the fact that it needs to be the same as the iInstruction tValue. This interface only has one method, the handle method, that accepts a tInstruction which needs to be an iInstruction of type tValue and a cancellation token. This method returns a task of tValue. Next are two marker handler interfaces which can be used to differentiate between command and query handlers if need be, both of which just implement the iInstruction handler interface. Last is the iInstruction dispatcher interface with its single method, sendInstruction. This, just like the handle method of the iInstruction handler interface, accepts two arguments, an iInstruction of tValue and a cancellation token, with the method returning a task of tValue. It may seem confusing, but all we are doing is just constraining types that we want to be able to send and receive via our dispatcher. Next, the actual implementation of the iInstruction dispatcher interface. I used a primary constructor to reduce the number of lines. The constructor accepts a func that takes a type and returns an object, which is used to resolve handlers from an IOC container. This approach enables resolution without coupling to any specific IOC framework, keeping the dispatcher lightweight and container agnostic. We will look at how we wire this up to an IOC container shortly. The private field in this instance isn't really necessary. I just have a habit of stashing the constructor argument values. Although the send instruction method may look a little scary if you have not used reflection before, it really isn't when you know what's going on. Let's break it down. On line 11, we are identifying the runtime type of the instruction that was passed in. For example, if the instruction is an instance of add customer command, the instruction type will be type of add customer command. Now that we know the instruction type, we need to determine the type of its corresponding handler. We start with the open generic type, iInstructionHandler, that all handlers ultimately implement. We call makeGenericType to fill in the type parameters, the first being the specific instruction type, add customer command, and the second being the return type, none in this example. The result, handler type, is the closed generic type for the exact handler we want to resolve from the IOC container. We now pass this handler type to our handler resolver function obtained via constructor injection. This delegate then asks the IOC container to resolve the type and return an instance of it. In this example, it will be an instance of our add customer command handler. Next, we get a reference to the handle method on the resolved handler type. Since all handlers conform to the iInstructionHandler of tInstruction and tValue interface, we know that the handle method exists. The return is where all the work gets done. We invoke the handle method on the resolved handler instance, passing in the instruction and the cancellation token as arguments. Since handle is asynchronous and returns a task of tValue, we cast the result accordingly so we can return it directly from send instruction. Back in the program file, let's look at how we configure either AutoFac or the Microsoft IOC container. First, AutoFac. You can add your instruction handlers manually or just let AutoFac scan your assemblies as shown. The most important part starts on line 41, where we have AutoFac return to us a constructed instruction dispatcher, supplying a function for the constructor argument that, given a type, will try to resolve an object from the container. So basically, our instruction dispatcher invokes this function supplying the type, and this function then has AutoFac try and resolve that type and return to us an instance of it. Next, the Microsoft IOC container. The Microsoft container, unlike AutoFac, does not have assembly scanning built in, but you can use packages like Screwtor, although I have not used it as AutoFac is the IOC that I generally use. The important line is line number 57, where the instruction dispatcher constructor is supplied with a function to resolve types from the container. And that's all there is to building a simple dispatcher that leans on an IOC container for type resolution. Having used this for several years now, I can say thus far, once configured, I have never had a problem with it. As mentioned earlier, the source code in this video now comprises of two projects, a demo and the project for the NuGet package, freely available on GitHub. Thanks for watching. As always, feel free to leave good or bad comments and I will do my best to answer any questions raised. Make sure to like the video if you did actually like it. Until next time, bye for now.